Main objective of a lightning-resistant system is to divert the electrical charge caused by lightning and thus negate its destructive potential. Lightning-resistant systems obstruct the flow of high-voltage electricity, redirecting it to be absorbed by Earth, thus saving buildings and its inhabitants from harm. Lightning conducting systems can be classified into two: external protection systems and internal protection systems.
We have learned that lightning protection systems are divided into internal and external protection systems. When we employ a method to safeguard ourselves, our homes, and our appliances from lightning and its devastating effects, it's important to ensure that the methods in use are effective and scientifically developed. If not, there'd be no guarantee that they would work during a time of need. It would be better to have an understanding of lightning conductors approved by the Bureau of Indian Standards and the IEC.
The external protection system consists of three main components: air terminal or interceptor placed above the building, down conductor, and earthing. In this system, the electric charge from the lightning is received by the air terminal and is sent through the down conductor and further to earth through the earthing system. Before employing a lightning conductor, the prospective buildings and geographical areas need to be carefully surveyed for the number of times the area is struck by lightning, the trees and tall structures near the building, the area of the building, the number of people living or being employed in the building, and the value of electronic appliances inside the building. The IEC recommends 4 levels of protection based on the factors listed before, from the high-level LPL1 to the normal LPL4 level. The air terminal is the metallic column placed at the highest point of the building. An air terminal can be made of any conductive metallic material. Bigger building complexes need more than just one air terminal. In such buildings, more air terminals are to be fixed. These air terminals are to be linked through copper, aluminum, or GI metallic strips to the earthing system. When the conducting systems are fixed, there are certain things to be extra careful of. Notice the picture. The air terminal fixed in this building offers no protection because the tree near the building is taller than the air terminal. When lightning strikes, it would strike the tree. The lightning would strike the tree and the resulting side flash would enter the house without any hurdles. There is something else too that needs to be remembered. The varying shapes seen at the tips of air terminals do not offer any special protection. The air terminal does not need any complex shapes. In buildings with heights of 60 meters or more, the risk of a strike is not confined to the top alone. Since the sides of the building too are vulnerable to attack, the edges of the buildings too are to be secured to the air terminals and down conductors. If the roof of the house is made of flammable material, the air terminal is to be placed at 0.15 meters above the roof. But if the roof is made of conductive metals, these materials themselves may be used as air terminals. There are 3 methods by which air termination system can be installed after taking the building's shape and structure into consideration. For houses with simple shapes, protection angle method can be adopted. The rolling sphere method is suitable for buildings of any shape. For houses with flat roofs, mesh method can be adopted. Apart from the air terminal, the down conductor is the most important component of the external protection system. The down conductor's function is to channel the electric charge captured by the air terminal to the earthing system. The down conductors are to be installed in a manner so as to enable the smooth flow of electricity speedily and efficiently to the earth. In buildings with complex shapes, all shapes and edges of the building are to be protected and connected to the down conductor and the earthing system. Any material with electrical conductivity can be used as down conductors. When the down conductors pass through external walls made of flammable material, a specific distance needs to be maintained between the wall and the conductors. When the arrestor system is installed in high-rise buildings, it is to be ensured that down conductors are installed every 10 to 20 meters. When down conductors are placed parallel to the roof, They are to be linked using ring conductors to prevent fire outbreaks. The earthing system is the third component in the external protection system. The earthing system carries the electricity captured by the air terminal and conveyed by the down conductor to the earth. GI metal sheets or copper wires are used for preparing the earthing system. The earthing system thus prepared is placed at a distance of 1 meter from the periphery of the building and at a depth of ½ meter. It is always ideal to set up ring conductors around the building instead of having multiple systems. In highly populated areas, it is better to install multiple ring conductors to prevent the dangers caused by step voltage. This is also considered to be the most effective system for residential buildings surrounded by trees.